friends, welcome to CAD Master ANSYS tutorial series. In this tutorial, we will learn the meshing. Meshing are very important part in ANSYS. This process is a part of preprocessor stage. ANSYS solver work with mesh model only. It cannot perform over solid model. Iterations perform based on computer shape and size. So let us see the meshing in details. Meshing is defined as the process of dividing the whole component into number of nodes and elements so that whenever the load is applied on the component, it distributes the load uniformly, called as meshing. In this figure, you will see that the component is divided into the node and element form. So this is the one element of this component, and the end of this element is called the nodes. So this is our mesh model. In this figure, you will notice that this is the solid model and this is the mesh model. Similarly, these two are the mesh components. There are two types of mesh control in ANSYS Workbench. First one is the global mesh control that is available under the detail view like this. Next is local mesh control. We will get the local mesh control once we right click on a mesh, and then we have to use the insert, and you will get the list of mesh control. That is the local one. So the difference between the local mesh control and the global mesh controls is that if you wish to control the component of assembly parts with the different detailing of mesh, then we can control it by using the local mesh control. Whereas global mesh control apply the same details over the components. Let us see the global mesh control in a detail. Physics-based meshing allow the user to specify the mesh based on the physics to be solved. That means we have to solve the mechanical or CFD or electromagnetic or explicit physics. In our case, we are using the mechanical. We have to define the physics type. That means solid element mid-side node, element shape checking, and transitioning. Then local mesh control. Local mesh control can be applied to either geometry selection or name selection. These are available only when the mesh branch is highlighted. Available controls include method control, sizing control, contact sizing control, refinement control, map face meshing, inflation control, and pitch control. This shows the local mesh controls. Once we right click on a mesh, we'll get the insert tab. Under insert menu, you will see the local mesh control. Once we perform the meshing or the geometry, then we get the different element shapes. That is hexahedron element is look like this. then tetrahedron, then parallel prism, and then perpendicular prism. So considering the geometry, shape and size, we get the different element shapes. We can control the element shapes by using the local mesh control. Let us see how to work with the local mesh control and global mesh control in ANSYS. Select the static structure from the analysis system and define the geometry as just a box by using the primitives. I use to create this primitives and then the box and define the parameter as it is. Once you click on a model, you will enter in mechanical environment. Under mechanical environment, you will see the geometry. Under geometry, you will see the solid body, then material, then coordinate system, and then mesh. If you select the mesh, you will get the details, and that details called the global mesh control. So if there is a assembly or the single component, then and if you want to control it by using the global mesh control, then you have to use all the parameters available under the details of mesh. It's having display, details, sizing, then quality, inflations, advance, and statistics. So here you will notice that under the display, you have to define the style. As there are different options available, we choose in this case the default geometry setting. Then defaults are the physical preference. From here, we can define the physics. As in our case, we are using the mechanical. If you wish to solve any CFD problem or a hydrodynamic problem or explicit related problem, then you have to change the physics from here. Element order, we choose under default, the element order are the program control. There are again types, that means the linear or the quadratic. Element size, we can control the element size by using this cell. If you wish to use the element size your own define, then change the parameters from here. Under sizing, you will see the different options. Keep these options as it is and change it whenever you require. The next options you will find the quality. So here it shows the check mesh quality, then error limits and smoothing mesh matrix. Keep these options as it is as per the ANSYS guideline. And we can change these options whenever we require. So we will see the requirement of changes of these options while solving the problem. There is one more tab called inflations. This part mostly used for cylindrical object or where we want to solve the CFD related problem. We will see this inflations in our next video. Then under advanced, you can keep the options as it is. Under statistics, you will get the number of nodes and the elements generated over the model. If you select on a mesh and use generate mesh, it will perform the meshing. and automatically you will get the mesh model, which is previously the solid model. Now, if you want to check the number of nodes and elements over this component, then use the statistics, and under the statistics, you will find the number of nodes and the elements. So this is all about the global mesh control. If you wish to control the object separately, then we use the local mesh control. For this, you have to just select the mesh and use the insert tab. And under the drop down menu of insert, you will find the different options available for controlling the local mesh. We will see the details of local mesh controls in the next video. This is the small introductions about the local mesh control and the global mesh control. Thanks for watching.